Today we are thinking about ordering some fractions. So when we order fractions, we either are asked to order smallest to largest, which is also known as ascending, or largest to smallest, which is also known as descending. So very simply, sometimes we'll just be asked to order fractions like this. Now these are really simple, so I'm just going to show you this very quickly. So in this example, all of the fractions, all of the denominators are the same. And just remember, when we're talking about denominators, we're talking about the bottom number of the fraction. So numerator at the top, denominator down at the bottom. Okay, so it's the denominators that we're really going to be focusing on a lot today. So in this example, all of the denominators are the number 8, which means they are eighths. Okay, so all I have to do, this example wants me to order smallest to largest, and actually all of the examples on the sheets that you've got this week, I'm pretty sure ask you to do smallest to largest as well. So we'll stick with that. So all I need to do, in this case, the denominators are the same, is I just have to look at the numerator, because remember the denominator tells us how many parts there are, and the numerator tells us how much of those parts we have. Okay, so for example here, as a quick reminder, if we think of it as, let's see, okay, so there's our eighths. If we think of it as like a pizza or a piece of cake, 3/8 would be 3 of those eighths. That's all that this fraction's saying here. So if I'm ordering smallest to largest, all I need to do in this example is find the one with the smallest numerator. So in this example, I can see that is 2/8. Now a good thing to do when you have written one of your fractions down when you're ordering is cross or sort of tick it so you know you've done that one and you don't end up accidentally repeating. Okay, after 2/8 then I can see it's the 3/8. Cross that one out. 5/8, 6/8, and then 7/8. So we have ordered those fractions smallest to largest, or in ascending order. Now this is really simple, and I know certainly you guys that I've taught this year, you can do that already. So the questions you've got this week are slightly harder than this. So there's a year 4 and year 5 sheet. It's all the same sheet to start with. There is a challenge sheet that I've aimed at year 5s. It's quite a bit harder. But the questions you guys have got this week, none of them are like that. I just wanted to do a quick reminder about that first of all. But in the examples I'm now going to show you, there's going to be different denominators. Okay? Now, all we do, I'll just get my next example. All we do when we have questions like this with different denominators, we need to turn some of these fractions that we've got into equivalent fractions to make them easier to order. So the aim is to make whichever fractions you've been given in your question, to make them all have the same denominator so it's easy for them to order, just like example 1 had. Okay, now what we'll do is just find equivalent fractions. So we're not changing the fraction, not changing it into something else. It has the same value, the same amount, it just looks different. So I often say same value, different appearance. Okay, so this example here is similar to one you have on your worksheet this week, where it gives you already the denominator that it wants you to turn these into. So some of the questions do that. So in this case, here's our 5 fractions. It wants us to order smallest to largest. And in this example, it's telling us it wants us to turn the denominators into 20, so into 20ths. Now, all we need to do, thinking back to how we find equivalent fractions, is I can see here actually the 2 already ended in 20 don't need to change, so I'm just going to write those in. Okay, so they don't need to change because they already have the denominator of 20. Now, with this one, for example, all I need to be thinking is, how, in terms of multiplying or dividing, how do I get this denominator to change into this denominator? So we're thinking again about our times tables. That's why they're so important in our maths. So I know that 5 times 4 is 20. So I'm just going to put a little times 4 next to there to remind me what we've done to get this 5 turned into a 20. Now, the key rule when we're finding equivalent fractions is whatever we do to the bottom, we do to the top. So because we've times this by 4, we're also going to times the numerator by 4. So this one is 4/20. So they are the same fraction, they are equivalent fractions. Now this one, I can see I need to times 10 by 2 to get 20. So I need to do the same to the top. So 4 times 2 is 8. This one, again, is a 10 denominator, so I also need to times this one by 2 to get 20, and then do the same to the numerator, 12. Okay, and we'd already done those. So we now have turned all of these fractions that we need to order into equivalent fractions. And now we can simply order them smallest to largest. Now it's up to you in your learning this week how you want to do this. You can either order the equivalent fractions that we've turned them into, or you can write down the ones we started with. It doesn't matter. Generally, in questions like this, you get the mark for whichever you do. Okay, so I'm going to do it first of all writing down the equivalent fractions, because that's quite straightforward for us to do. So I can see actually that the smallest one is the one we've already got here, so 3/20, cross it out. The next one would actually be 4/20, cross it out. Next one would be 7/20, cross it out. Next one would be 8/20, cross it out, and 12/20, cross it out. Again, you could have just written them as, so 3/20 would have been the same. 4/20 I would have written 1/5 there. 7/20 is the same. 8/20 I could have written 4/10 there. And 12/20 I could have written 6/10 there. Okay, I'm going to show you another example similar to that, just for a bit more practice. So example 3 is very similar to the one I've just shown you, but just different denominators. So the only difference in this one is some of the questions on your sheet will not have the denominator there ready for you. So if we look back at example 2, the question had told us it wants us to change them into 20ths. But in this question, this is where it's slightly harder, it's not telling us what to do. We've got to work that out ourselves. So what I'm going to be doing is looking at our denominators and thinking, okay, is there a denominator they have in common? Is there one here that I can already use? That's what I want you doing for most of the questions that you get. There will be usually a denominator that you can change them all into that's already there. Often it is the one with the largest number at the bottom. That doesn't mean it's the largest fraction. Certainly largest number at the bottom does not normally mean the largest fraction, but we're just looking for the means of converting into equivalent fractions, which, if we ignore these as fractions for now, which of these numbers is the biggest. Okay, so in this case it's 12, so I'm going to change all of my fractions into 12. So that means I can keep these as they are, 5/12 and 1/12. Okay, sometimes you might have to change it to a smaller one, but in most of the examples you've got today, this method works best. So we've got those done ready. We now need to start here and think, okay, if I'm making this into 12s, what do I times 3 by to get 12? So 3 times 4 is 12. But whatever I do to the bottom, I do to the top. 2 times 4 is 8. I want to make this one into 12s. At the moment I've got a 6, so I need to times it by 2. But whatever I do to the bottom, I do to the top. Times by 2, so that becomes 6. And the 1 at the end, again, we also want to change this into 12s. This one is another 6th. So we're going to times by 2 to get 12, times by 2. So 5 times 2 is 10. Now again, like on the previous question, all we need to do is order these now smallest to largest, either writing down our equivalent fractions or writing down what we had originally, it doesn't matter. So again, just for speed, I'm going to write down the new version here. So 1/12 would be the smallest, followed by 5/12, followed by 6/12, followed by 8/12, and then 10/12. And again, like I said earlier, you could write down, so they're the same, so it wouldn't make a difference. 5/12 is also the same, so that wouldn't make a difference. 6/12, you could write down 3/6, the original one we had there. 8/12, you could write down 2/3, and 10/12, where are we? Oh, so that would be 5/6. Okay. Now, slightly harder. This example I'm now going to show you is an example of the challenge sheet, the Year 5 challenge sheet that I have added to our learning this week. So what makes this harder is, again, you're not told what to convert the denominators into. You have to work that out yourself, but also from question D onwards on these questions, the denominators that are here, you're not going to be able to use one of those to turn them all into equivalent fractions. So what we have to do instead, I've put here, so you can't use any of the denominators that are in the question. Instead, you have to find a common denominator by thinking about multiples of each number. So I'm going to think about my multiples of 4 and just count on a few times in 4s and remind myself. I'm just going to note these down underneath. So 4, 8, 12, 16, 20, 24, 28. I'll stop there, I think, for now. Don't need to do my whole times table, just doing a few to get me going. Okay, now 8, 16, 24, 32. I'm going to stop there for now. And 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, oh, we're in our room, 26. I'll stop there for now. I'm going to go up here for this one. So, in fact, I can use both the space because both of these are 6 anyway. So, 6, 12, 18, 24, 13. I'm going to stop there for now. I've kind of just gone up to no more than 30, 32 in all of these. Now what I'm going to do, now I've looked at my multiples, I want to find a common one, okay, so one that they've got in common. So I'm going to scan across and think, okay, which here do they all have in common? Now when I first start to look, I think, oh, actually, 8 looks like a possibility. 8, 8, 8. But then when I look at my multiples of 6, it's not going to work because when I'm counting my 6's, 8 is not a multiple. So that's not going to work. So I look across again and think, okay, so another one they've got in common. 16 looks quite common. So 16, 16, 16. No, it's not going to work because we've not got that here. So again, I'll look across. 24, 24, 24, 24. Okay, so they are all multiples of 24. So that is going to be my denominator. Okay, I'm going to do what we did on the last question. We're going to turn these now into equivalent fractions. So I need to think, what have I times 4 by to get 24? And I've times it by 6. So whatever I do to the bottom, I do to the top. So 3 times 6 is 18. Next one, I've got 8 here, and I've got 24 here. So I need to times that by 3 to get to 24. Whatever I do to the bottom, I do to the top. So I'm going to times that by 3 and get 15. Next one then, I need to times this one by 12 to get to 24. Whatever I do to the bottom, I do to the top. So 1 times 12 is 12. Okay, this one we have 6, trying to get it to 24. So we're going to times that by 4 and times that by 4. And then this bottom one, again, it's another 6. So we're going to times that by 4 to get 24 and that by 4 to get 8. Okay, so exactly the same as with the questions, it's just a step harder having to work out our own denominator and it not being one that's here. We have to count on in our multiples of that number to find a multiple that they've got in common. Okay, remember year 4s, this might be slightly too hard for you unless you did fancy a challenge. This is more aimed at year 5s, and even some year 5s, really don't worry if you find question D onwards tricky on that last sheet. Final job then, we need to order them. So again, I'm going to use the converted ones just to make it easier. So where are we? Smallest to largest again, 8 over 24. Oh no, 4 over 24, nearly missed that. 8 over 24. 12 over 24, actually equivalent to a half as well, which we had originally there. 15 over 24. Finally, 18 over 24. Now your answers on this sheet, they do, once they're ordered, I'm pretty sure from what I remember, they're written as the original ones, but that's quite straightforward for you to spot once you've written them out, just matching them up there, okay? So hopefully that is a little refresher for fractions. It's been a while since we've done fractions. We were literally about to spend 3 weeks on our fraction learning just before school ended. So I thought we'll pick this because we've not done it in a while, and a few of you have requested some fractions learning. So hopefully that's a bit of an extra reminder, remembering this is quite hard, and I'd only be expecting you to do this last example, that harder sheet, if you find you flew through the other sheet first of all and want a challenge. Okay, as always, do get in touch if you need any harder examples or if you want me to check anything through for you. Okay, take care, bye.